Hello, grade 4 teachers. Let's look at some ways that you can connect the computer sciences into your matter unit. We know that the computer sciences organizing idea all the way from kindergarten through grade 6 talks about creativity, design, and computational thinking. And there are lots of ways that you can incorporate this into your other subjects and classroom routines. You may find that you need to look back in the curriculum to see what was in the previous grades to make sure that your students have those learning outcome understandings from the lower grades. The nice thing about the computer science curriculum is that it talks a lot just about understanding, following, and creating instructions, which is something that your students have been doing ever since they've been coming to school and probably even before, by making quick references to things like what's the process you use to brush your teeth, and having students break that down into an algorithm. You're going to just refresh those early on learning outcomes so that you can dive into the grade 4 outcome, where we're really starting to look about design thinking, and we're talking specifically about computer science and technology. So in grade 3, students learn about what computational thinking is. That's a piece you may need to bridge that gap for your grade 4 students. And then in grade 4, we start to talk about what design thinking is. So this is where you'll be trying to connect design thinking in as much as you can throughout your classes, throughout your whole year. It's a big idea. It comes into play further on through the science and elementary, and is really a valuable life skill that we want our students to start learning early on. So anytime you can make that connection to the design process in your science units, in your other units, you're going to just help cement that for your students. So we see that we are actually creating an artifact in grade 4. So further along in this video, I'll show you a couple of different Scratch projects that are going to meet this CS outcome while also covering those matter topics. And we see that the design thinking really remains the understanding, but there's a lot of knowledge around the computer sciences and coding and what artifacts are. So there really is a lot of knowledge in your computer science that you're going to be embedding into your other teaching to make those connections. When we teach students about creativity in problem solving and design thinking, we're really looking at creative new ways to solve problems. So we should always be referencing creative thinking, what's another way to do this, and thinking about how we can be creative when we're solving problems, whether it be in science, math, language arts, or just our daily lives. The design thinking process. This is what you are being asked to explicitly teach and ensure that your students understand. I would start your year early by working through these steps and getting students to understand the different pieces of the design process so that it's easy to reference them when you're using these skills in other areas. And then again, computational thinking is not explicitly in your curriculum with the verbiage and language, as students should understand this, but it was supposed to have been taught in grade 3. So if you're optionally implementing the science, or even if your students had it in grade 3, you're going to want to just check in, make sure they understand the components of computational thinking. And again, there's opportunities to reference these steps when we're doing these skills throughout our classroom routines and other lessons and activities to keep this always a piece of what we're doing with the students, and to really connect this into creative thinking in all areas. So the first Scratch project that I have that you can do with your students is have to do with creating a garbage game. You're going to hit a whole bunch of the computer science skills and procedures by having the students create a game in Scratch. We're also going to be involving the design thinking process when we're doing that creation. In particular, depending how much customization and how much of the work you have the students do on their own, you'll be involving more of that design thinking process. We can have them work with partners or in groups to do their programming, their designing, their planning, and we're going to meet this collaboration piece. And anytime we're working in some type of a programming language, we're building algorithms. So we're definitely applying that computational thinking too. And we're going to be thinking about ways to do waste management in this game also. So this is just a little clip of what the game example that I built looks like. We have some of the bins. This comes right out of the knowledge in your matter curriculum. I didn't include some of the others. They had a repurpose and fix, I think, or a couple more options in there. Certainly if your students are already familiar with Scratch, if they use it a lot, I would highly encourage you to go with the cards, which is the first link here at the top, and ask students to create the sprites and the backdrop and everything themselves. If your students need a little bit more scaffolding, or if you want to check out the template yourself, the other link leads to the actual template in Scratch. So the template has the background all set, the sprites are all there already created. All of the code is not there. So that is just a place to come in and start building those codes. Either of those are easily usable with your students. And then, as I say, if you get your students to go ahead and create the game, come up with what, those different pieces of garbage that the sprite is dropping are, then they're going to also be really showing that they understand that matter concept by putting the appropriate garbages into the right places in that game. So as I say, there's the links. You can check that out, share them out with your students, and have them build their own awesome garbage game, and definitely encourage them to go beyond what is in those cards too, and just build and create with that Scratch interface, and you're going to be meeting lots of computer science stuff. All of my Scratch cards, as I say, have the code blocks all lined up for the students, but always, I encourage kids to build their projects from scratch and work with the sprites themselves. Canva is how I create all of my content for Scratch. It's a great way to make sprites and backgrounds. You can create transparent sprites without that box around them, and that's how all of the graphics in my games have been created. So if your students have access to Canva, they can easily make their own custom sprites and backgrounds as well. Shifting into really applying that design thinking piece, because that's a part of your computer science curriculum that needs to be explicitly taught. As I say, you want to make connections to that as often as possible. So when we're trying to meet this skill and procedure where we're asking students to develop a personal plan about reducing waste, we can work them through the design process. So the empathize piece would be a discussion about the why. Why do we want to develop a plan to reduce how much waste we create? And this is where we are going to think a little bit more globally, and how do you think people in the future are going to feel about there being a garbage problem in the world? Or how do you feel about how do you think the animals feel about their natural habitat being taken over by landfills or pollution and those kinds of things? So we can have those conversations about the why we want to develop this plan. And then as we start to move into, well, what is my waste? How much garbage do I produce? And how the students start, defining and analyzing what their waste contributions are, and then move into the brainstorming. Well, how can you personally reduce this waste? So this is now I'm coming up with this plan, and then we're going to put this plan into action and see if it works. Do I manage to reduce my waste? And there's my sort of prototype piece of the design process, and then by following through on the plan to reduce the waste, and then obviously at the end seeing, was that a good plan? Did my plan to reduce waste work? Did I produce less garbage? We've worked through the design process. We can tick off that computer science piece about design thinking, and then also have met this skill from the matter unit. anytime you're asking students to create a process, we could be talking about life cycles or nitrogen cycles or how ecosystems function or representing a recycling process. We're asking students to take a process, break it down into its steps. So we're 100% working through that computational thinking. We're decomposing, we're recognizing patterns, we're abstracting those patterns and applying them, simplifying, getting to the basic parts, and then putting those specific steps in order to create that algorithmic thinking. And we can take that, we've already covered the computational thinking, we're really already doing the algorithmic thinking. But we can also connect directly, talk about algorithm design, go to that next step, ask students, how would you write a set of instructions for this for a computer or for another human to follow? And then we're really, really directly connecting that algorithmic thinking from the computational thinking into this matter concept. And if we ask students to think about now other recycling processes and how that set of instructions may apply or might have to be adjusted or changed for that, we're really going to get into abstracting and thinking about that context in different ways, which is a really great way to just take that computational thinking up to a bit of a higher level and make sure that your students are experiencing as much of it as you can expose them to. I have another scratch game regarding this hazard symbol concept. This is a pretty simple one. Again, if you have the students create the sprites and sort of build the whole game themselves, they're really going to be showing you more of the skill and process that comes specifically from Matter. If you use my template, a lot of the sprites are already labeled, they're created, they're there. So some of that concept knowledge is in the game, which makes it really good for teaching this Matter concept, but maybe we're not assessing it in this case. Though having students build the whole thing from just having looked at the exemplar would be a way to meet all of these CS skills as well as show that they know this Matter skill. So the hazard game is a really simple one. This would be great for your students, especially if they haven't used Scratch before. It's a good beginner project with pretty basic coding and teaches them a bit about variables and some random selection. The links and the QR codes here can be shared directly with your students. The cards take you to my Scratch cards, which have all of the pieces, the blocks laid out for the students. The template takes you to a copy of the project with just the sprites. Students can remix it and they're ready to roll. Moving on to this last skill and procedure about discussing responsible use. I don't have a Scratch project created for this, but by the time your students did the previous two in this session, they would definitely probably be able to come up with something along this just based using what they've already learned in Scratch. And in particular, if they have used it previously in a younger grade or you've been using it with them, they could certainly come up with some type of a Scratch game that would demonstrate responsible use and disposal. They could build on the previous game from the garbage game with the different recycling bins and put in some different sprites to really talk about that responsible disposal as well. You could have them work through Canva again to create sprites and backgrounds for a game in Scratch. And if they are doing that, then again, they're working through those computer science outcomes. They're building an artifact, they're working with some block coding, and they're applying computational thinking and design thinking into creating their own projects. So you could really have them meet a lot of these skills and learning by doing a project that they build from scratch where they decide completely what that game is going to be about, and you'll be able to then assess what they know about this Matter skill as well as all of the computer science skills. That is how you can connect computer sciences into your Matter. I hope you enjoyed.